Imagine a headline: astronomers confirm the universe is mostly empty. We gaze at the night sky, dazzled by stars and galaxies, but it's an illusion. The truth? Galaxies are tiny islands in a vast, dark ocean of nothing. Our telescopes once focused only on the bright spots, missing the immense voids in between. As our cosmic maps improved, we realized the universe is defined as much by emptiness as by matter. These voids, silent, empty kingdoms, dominate the cosmos. We thought we lived in a crowded universe, but we're more like a remote lighthouse on a lonely coast. Understanding these voids is one of science's greatest adventures. What are these immense regions of emptiness? How did they form? What secrets do they hold? The answers challenge our deepest assumptions about reality. The great emptiness is calling, and we're just beginning to listen. So, let's embark on a journey beyond our galaxy, past clusters, into the mysterious darkness between. We'll travel across billions of light years to confront the largest structures ever discovered, the cosmic voids. To truly understand the universe, we must explore not just its brilliant islands of light but also its vast, silent oceans of nothing. Let's begin. To grasp the great emptiness, we need a map, not of stars, but of galaxies. When astronomers charted galaxies, they found not randomness, but a vast, interconnected structure, the cosmic web. Imagine a sponge, strands and sheets of matter surrounding empty pockets. The strands are galactic filaments, hundreds of millions of light years long, where galaxies are strung like pearls. Where filaments intersect, we find dense galaxy clusters. The sheets are the Great Walls, enormous, flat surfaces of galaxies. Our Milky Way is part of one such wall, the empty pockets. Those are the cosmic voids, vast, dark regions surrounded by filaments and walls. A typical void spans 100 to 400 million light-years across. Inside, the density of galaxies is less than a tenth the cosmic average. These are the deserts of the universe, where cosmic activity fades to a whisper. This spongy structure is gravity's masterpiece, sculpted over 13.8 billion years. Tiny fluctuations in the early universe grew into filaments and clusters. The emptier regions became the voids. The result, a universe where the rich get richer and the voids grow ever emptier. The story of the cosmos is written in both its light and its darkness. Our journey begins on Earth, orbiting an ordinary star in the Milky Way. The Milky Way is a spiral galaxy, home to over 100 billion stars. We're not at its center, but in a quiet suburb called the Orion Arm. It takes our sun 230 million years to orbit the galaxy's core. For centuries, we thought the Milky Way was the entire universe. That changed when Edwin Hubble proved other galaxies existed, vastly expanding our cosmic perspective. Our galaxy is just one among billions. Our cosmic address: Earth, Solar System, Orion Arm, Milky Way. But to find the great voids, we must zoom out, beyond our galactic home, to the grander structure of the universe. Only then do we see the true scale of the emptiness that surrounds us. The Milky Way is part of the Local Group, a family of over 80 galaxies, dominated by the Milky Way and Andromeda. Andromeda, our largest neighbor, is on a slow-motion collision course with us, set to merge in billions of years. The Local Group also includes the Triangulum Galaxy, and many smaller satellites. Zooming out, we find the Local Sheet, a cosmic pancake of galaxies. This sheet is part of the Virgo supercluster, a sprawling collection of at least 100 galaxy groups and clusters. At its heart is the Virgo cluster, a dense swarm of over 1,000 galaxies. Our Local Group sits on the supercluster's fringe, like a small town on the edge of a metropolis. Our full address: Earth, Solar System, Milky Way, Local Group, Local Sheet, Virgo supercluster. And here, at the edge of our supercluster, we finally confront the great emptiness. Beyond this point, the universe's structure gives way to the vast, silent voids. The crowded lights end and the darkness begins. This is where the true scale of cosmic emptiness reveals itself. Standing at the edge of the Virgo supercluster, we peer into a cosmic void. These voids are not just empty spaces, they're the dominant feature of the universe's large-scale structure. If galaxies are cities, voids are the vast, empty continents between. The local void, right next door, stretches for 200 million light-years. Our Local Group sits on its edge, pushed away by its emptiness and pulled toward denser regions like Virgo. Another example: The torus void, a classic region of emptiness surrounded by filaments. Inside a void, you'd see almost nothing for millions of years, just a few faint galaxies in overwhelming darkness. Voids aren't perfect vacuums. They contain sparse matter, thin hot gas, and a few isolated galaxies. More importantly, they're dominated by dark energy, which accelerates the universe's expansion. In dense regions, gravity resists this expansion, but in voids, dark energy rules. Voids are growing, getting emptier and larger, pushing galaxies further apart. They are, in a sense, the future of the universe. The emptiness is not just absence, it's a force shaping cosmic destiny. The more we study voids, the more we realize how much they define our universe. The great emptiness is not a backdrop, it's the main stage. For years, astronomers thought voids were true deserts, completely empty. But as our surveys deepened, we found galaxies adrift in the darkness. One famous example, NGC 6503, the lost-in-space galaxy, isolated on the edge of the local void. Unlike the Milky Way, surrounded by companions, NGC 6503 is almost entirely alone. These void galaxies are smaller, bluer, and more gas-rich than those in crowded clusters. They evolve in isolation, untouched by galactic collisions or mergers. Studying them offers a glimpse into galaxy evolution in its purest form. They're like time capsules, preserving the conditions of the early universe. By comparing void galaxies to those in clusters, we learn how environment shapes cosmic evolution. In the void, a galaxy's fate is determined by its own gravity and gas, not by neighbors. These lonely islands teach us about nature versus nurture on a cosmic scale. Even in the emptiest places, the universe finds a way to create and evolve. The voids are not barren, they're laboratories of cosmic solitude. The story of voids begins with the Big Bang, 13.8 billion years ago. The early universe was nearly uniform, but tiny quantum fluctuations created slight differences in density. Gravity amplified these differences. Denser regions pulled in more matter, forming filaments and clusters. The less dense regions lost matter, becoming emptier over time. These underdense bubbles became the cosmic voids. Voids didn't push matter out, matter simply left, drawn to the growing structures. That's why voids are so round. Matter is pulled away from all directions. As the universe expands, voids grow even faster, stretching and merging. In the far future, voids will dominate, leaving galaxy clusters as isolated islands in an endless dark sea. Not all voids are equal. Some are truly colossal. The KBC void, named after its discoverers, is the largest known, 2 billion light-years across. Our Milky Way, local group, and much of the Virgo supercluster sit inside it. Living in such a vast void may explain why local measurements of the universe's expansion differ from distant ones. The reduced gravity inside allows our region to expand faster than average. Another mystery, the Eridanus void, or CMB cold spot, a huge cold region in the cosmic microwave background. It may be caused by a supervoid up to 1 billion light-years across, sapping energy from ancient light as it passes through. Such giant voids challenge our standard cosmological models. Their existence could be a statistical fluke, or a sign of new physics. These cosmic giants are not just empty. They're puzzles that could rewrite our understanding of the universe. The voids are more than gaps. They're clues to the universe's deepest mysteries. The emptiest places may hold the biggest secrets. The discovery of cosmic voids has transformed our view of the universe. The cosmos is not a random scatter of galaxies, but a structured web of matter and emptiness. Voids are not passive. They shape the evolution of the universe and challenge our theories. Their sheer size pushes the limits of our cosmological models. Voids are the ultimate laboratory for studying dark energy, the force accelerating cosmic expansion. In the voids, dark energy reigns supreme, offering clues to its true nature. The great emptiness teaches us humility. We live on a tiny speck, on the edge of a vast, silent void, but this perspective should fill us with wonder, not insignificance. In this vast, dark cosmos, a small part, us, has begun to comprehend the whole. The great emptiness awaits, full of secrets, and our journey into it has just begun.